So question number 6, let me write it down first. Use the following figure. Use the following figure to prove that number 1, R is the midpoint of BC, and part 2 is twice of PR is equals to AB plus DC. The figure is like this. So this is the figure. This is A, this is B, C and D, P, Q, R. We are given this and this are equal, this part and this part are equal, and CD and AB are parallel to each other. So in order to solve this, the first part of the question, R is the midpoint of BC, is very much clear if you look it in the diagram. If you look in the triangle ABG, P is the midpoint of AD and Q is the midpoint of BD. It is already given. So we have PQ is parallel to AB and PQ is half of AB. Now we have to prove that R is the midpoint of BC. Now if you look at this triangle BCD, Q is the midpoint which is already given and QR is parallel to CD. Why? Because we have just now proved that PQ is parallel to AB and AB is parallel to DC. So QR is parallel to DC. So Q is the midpoint and QR is parallel to DC. So we can say that R is the midpoint of BC. So write down AP equals to DP, the information that is given. AP is equals to DP, DQ equals to BQ, DQ equals to BQ. So P is the midpoint and Q is the midpoint. So therefore PQ is parallel to AB and PQ is half of AB. Now from this we have PQ parallel to AB. Now in triangle BCD, Q is the midpoint of BD. Q is the midpoint of BD, which is already given. Now we have proved that QR is parallel to DC because PR is parallel to AB and PR is parallel to DC. So PQ is parallel to DC, that is QR is parallel to DC. So we have QR parallel to DC, that is proved. So therefore R is the midpoint of BC, and this is by the converse theorem. If you remember the converse theorem, so this is obtained by applying the converse theorem. Now second part of the question is twice of PR is equals to AB plus DC. Now since Q is the midpoint of BD, R is the midpoint of DC, so QR is parallel to DC and QR is half of DC. Now we can write here PQ is half of AB and QR is half of DC. So what we can do? We add these two, PQ plus QR. Adding this, so PQ plus QR is half of AB plus half of DC. So this we can write half of AB plus DC if you take half common. So 2 multiply, now PQ plus QR, PQ plus QR is PR. So PR is equals to half of AB plus DC. So we can write twice PR is equals to AB plus DC. So this proves the second part, and here it is the first part. Simply the application of the midpoint theorem and its converse. So now just have a look into this question, then we move on to question number 7. Question number 7 is, the following figure shows a trapezium ABCD in which AB is parallel to DC. AB is parallel to DC. P is the midpoint. P is the midpoint of AD and PR is parallel to AB. Prove that PR equals to half of AB plus CD. Now the diagram is, this is the trapezium, this is A, B, C and D is the trapezium. PQR, this is P, this is Q and this is R. This is the diagram. Now what is given? This AB is parallel to DC. AB is parallel to DC. P is the midpoint of AD. P is the midpoint of AD, that means this part and this part equal, and PR is parallel to AB. So all three are parallel. AB is parallel to DC given, then also it is given PR parallel to AB. So AB is parallel to PR is parallel to DC. Now you have to prove that PR is half of AB plus CD. This result is very important result in terms of the figure trapezium. So this result you can apply in some geometrical proofs, like the value of PR is half of AB plus CD. Anyway, we have to prove this particular thing, that PR is half of AB plus CD. Now similarly we can prove that AB is parallel to, given AB is parallel to DC and PR is also parallel to AB. So we can say all the three are parallel to each other. Now in triangle DAB, in also it is given P is the midpoint of AD. So in triangle DAB, what we have? P is the midpoint, PQ is parallel to AB, so Q is the midpoint of BD. P is the midpoint of AD, which is given PQ is parallel to AB. That is also given. So what we can say that Q, therefore Q is the midpoint of DB or BD. So Q is the midpoint of BD. Now similarly, if you take the triangle BCD, we have Q is the midpoint of BD and QR is parallel to CD, so R is the midpoint of BC by again the converse theorem. So here it is the converse theorem. So again move on to this triangle DBC, or you can say BCD. So in triangle BCD, what we have, Q is the midpoint of BD. Q is the midpoint of BD, which you have just obtained. Q is the midpoint of BD. QR is parallel to DC. QR is parallel to DC. So what you can say that R is the midpoint of BC. So you can say R is the midpoint of BC. So in both the cases we have acquired the result by applying the converse theorem. So now we have to prove that PR is half of AB plus CD. It is exactly the same what we did in the previous question. So what is PQ? I will drop this side. PQ is half of AB and QR is half of CD. So therefore if you add this PQ plus QR, that is half of AB plus half of CD, and PQ plus QR is PR. PQ plus QR is PR, and that is half of AB plus CD. Finally we have proved this identity. So look into this, then we move on to another question. This is question number.
This can also be, sir.
Yeah.
Line segment joining the non-parallel side. Midpoint of non-parallel side is equal to half of parallel side.
Yes,
Parallel side.
that is what I told you in the beginning. This is the property you can use for trapezium. The P are the midpoints of the non-parallel sides of a trapezium. If you take it, then this length segment PR will be half the length of the sum of the length of the two parallel sides. That is the property of a trapezium. This is what you have proved here. So in case that property of trapezium is asked to prove, then this is how we can also prove that property of trapezium. So now moving on to the next question. Question number 8. So let us take question number 8. In the given figure, AD and CE are medians. And DF is parallel to CE. Prove that FB 1 by 4 of AB. So let us draw the diagram first. This is the triangle, this is the median, AD and CE. So triangle is A, this is B and this is C, and we have this is E and this is D, and this one we have to draw. So D and E are the midpoints of the sides BC and AE. Since it is given AD and CE are the medians, so D is the midpoint of BC and E is the midpoint of AB. So now CE, since CE is the median, we have E is the midpoint of AB. Then triangle BCE. Let us move on to this triangle. In triangle BCE. In triangle BCE, what do you observe? That BE is, in triangle BCE, D is the midpoint of BC, right? D is the midpoint of BC, and DF, this is F. Oh, it is given, I am missing it out. DF is parallel to C. I have not written, so a little confusion. So DF is parallel to CE. So we have F is the midpoint of AB. Okay? So in triangle ABCE, D is the midpoint of BC, DF is parallel to CE, which is given. So therefore F is the midpoint of BE. F is the midpoint of BE. This is again, we have obtained this result by using the converse theorem. Go through it once again. In triangle BCE, D is the midpoint of BC, DF is parallel to CE is also given, so we can say F is the midpoint of BE. Now we can write FB is half of EB. FB is half of BE, right? And BE is half of AB. So you can write half of BE is half of AB because E is the midpoint. So we have 1 by 4 AB. So finally we got FB is equals to 1 by 4 AB, and this proves the identity. So now we can move on to the next question, that is question number 9. In triangle ABC, AD is the median, AD is the median, and DE is parallel to BA, where E is a point in AC. Prove that BE is also a median. BE is also a median. Let us draw the figure first and then we will apply the appropriate theorem. This is the triangle, supposing this is A, B and C. Now given AD is the median, so let us draw AD. So D is the midpoint of BC since AD is the median. Then DE is parallel to BA where E is a point in AC. So let us AC. So let us draw DE parallel to BA. This is BA, so we draw a line parallel to this. So this line and this line are parallel and we mark it as E. So we have to prove that BE, I repeat, question is BE. Obviously I don't think it is BE, this is will be DE. DE is also a median. So how can you go with this? So in triangle ABD, if you look into this, in triangle ABC, D is the midpoint of BC and DE is parallel to AB. So E is the midpoint of BC. Very simple question. In triangle ABC, D is the midpoint of BC. DE is parallel to AB. So therefore E is the midpoint of AC. Hence we can say that therefore DE is a median. Since E is the midpoint, so we can say the line segment DE is the median of the side AC. So this is question 9. Let us take another question. Very simple question it was. Question number 10. In triangle ABC, DE and F are the midpoints of the sides. D, E, F are the midpoints of the sides AB, BC and AC. AB, BC and AC respectively. Prove that AE and DF, AE and DF bisect each other. Prove that AE and DF bisect each other. Now let us first draw the diagram for this. In triangle ABC, DE and F are the midpoints of the sides AB, BC and CA. Let us draw the diagram. ABC, D is the midpoint of AB, E is the midpoint, D is the midpoint of AB, E is the midpoint of BC and F is the midpoint of AC. Prove that AE, that means this one, if you join A to E, AE and DF, these two, AE and DF bisect each other. So if DE and F are the midpoints of the sides AB, BC and AC, and if you join A and E, this and D to F, then these two bisect each other. That means they divide each other in equal parts. So how to proceed? So E and F are the midpoints. If we join this, let us join this and also join this. Now if you see into the figure, E is the midpoint, F is the midpoint, so EF is half of AB and is parallel to AB, right? So DE, similarly DE is half of AC and is parallel to AC. So what we can write? D and E are the midpoints of AB and BC. So you can write D is parallel to AC, DA is parallel to AC. Similarly, E and F, as I told you, E and F are the midpoints of BC and AC, BC and AC. So what we can write? So we can write EF is parallel to AB, therefore EF is parallel to AB. So what we finally get, that ABEF, ABEF, this ABEF, let me do ADEF. So if this is parallel to this and this is parallel to this, so you can say ADEF is a parallelogram. Therefore ADEF is a parallelogram. Why? Because the opposite sides are equal and parallel. If this is the midpoint, then this part and this part are equal. If this is the midpoint, then this part and this part are equal. So opposite sides are parallel as well as equal. Hence, ADEF is a parallelogram. So we know that in a parallelogram, the diagonals bisect each other. So AD and DF bisect each other by the property of parallelogram. So you can directly write AG, let it be P. The property of a parallelogram is that the diagonals bisect each other. Diagonals of a parallelogram bisect each other. Hence, we can write that AP equals to EP and DP equals to FP. DP equals to FP, which proves the condition in the question. Hopefully it is clear. Now you move on to question number. Which question is? What was the question number? This one?
10.
So we move on to question number 11. So moving on to question number 11. In triangle, let me take another question here. In a trapezium ABCD, in a trapezium ABCD, sides AB and DC, sides AB and DC are parallel to each other. Are parallel to each other. E is the midpoint of AD and F is the midpoint of BC. F is the midpoint of BC. prove that AB plus DC is equals to twice of EF, 2EF. In a trapezium ABCD, sides AB and DC are parallel to each other. So now let us draw the diagram here. This is the trapezium. We can draw this, name it as ABCD. What else is given? And sides AB and DC are parallel, so let this mark it as D. E is the midpoint of AD. E is the midpoint of AD. And F is the midpoint of BC. F is the midpoint of BC. So you have to prove that AB plus DC equals to twice of EF. I think the same result, isn't it? So anyway, let us do it. What we do here in the previous question, that the segment joining this is half of AB plus DC. I think this question we have solved. So let it be. We don't do it right now. Take the another question. Note the question and keep it. Similar type question since you have already done. So I am moving on to some other question. In a parallelogram, ABCD, E is the midpoint of AB. E is the midpoint of AB and AP is parallel to EC, which meets DC at point O. And BC produced to P, and BC produced to P. Prove that BP equals to, number 1, BP equals to twice of AD, and number 2, O is the midpoint of AP. O is the midpoint of AP. Let us now first draw the diagram. We need to draw the parallelogram first in a parallelogram ABCD. In the diagram, if it is ABCD, E is the midpoint of AB. So this is the midpoint. AP parallel to EC. AP, where is P? AP parallel to EC. This is the line EC. Let us join this first, EC, and where will be P, which meets DC at the point O. E is the midpoint of AB and AP parallel to AC now, which meets DC at the point O. This is the point O. And BC produced to P. So this you have to produce. Now this is the diagram. So let us understand this diagram once again. In a parallelogram ABCD, E is the midpoint of AB. We have drawn the parallelogram ABCD, E is the midpoint of AB. AP, this is AP which is parallel to EC, which meets DC at O and BC produced at P, produced to P. Okay, now we have to prove that BP is twice of AD and O is the midpoint of AP. Okay, ABP, this triangle, we need to prove BP equals to, BP is twice of AD. So first of all, this is a parallelogram, so the opposite sides are equal and parallel, we know that. So this side and this side are equal. Now if you have to go with this, in triangle ABP, E is the midpoint of AB, that is given, this is the midpoint. AP parallel to EC, so these two are parallel. So E is the midpoint, these two are parallel, so C is the midpoint. So let us write in triangle ABP. In triangle ABP, E is the midpoint of AB. EC is parallel to AP, or we are given AP is parallel to EC. So therefore, C is the midpoint of BP. So C is the midpoint of BP. So we have BC equals to PC. BC equals to PC is equals to half of BP. Now since BC is half of BP and since BC equals to AD, we can say that AD is half of BP, right? So we can write here BC is equals to AD, because they are the opposite sides of a parallelogram which are parallel as well as equal. So BC equals to AD and that is equals to half of BP. So we can write BP is equals to twice of AD. The first part is proved. And then O is the midpoint of AP. O is the midpoint of AP. So this is the midpoint in this triangle again ABC. This is the midpoint. This is parallel to this. Hence O is the midpoint. So let us again write in triangle ABP. C is the midpoint of BP. AP is parallel to EC, so therefore O is the midpoint of AP. So second part is also proved.